Well, the problem we're doing now is a distance rate time problem. So we know this: rate times time equals distance. In other words, if you travel 60 miles an hour for 2 hours, you go 120 miles. And we can take this equation and solve for t, and t equals d over r. We can solve for r, and r equals d over t. So we're going to build a chart, and rate times time equals distance. Now here's the question. A faucet can fill a sink in 5 minutes. Okay, so faucet. How long does it take to fill the sink? 5 minutes. And this equals one sink. A drain, so the drain, a drain will empty the same sink in 8 minutes. And that's one sink. Distance. And so now, what's the rate? Well, the rate is distance over time, so 1/5. What's the rate? The rate is distance over time, 1/8. And now the question is, how long is it going to take to fill the sink, one sink, if you turn on the faucet and open the drain? In other words, you've got water going in, water going out. That's why you have a difference. Well, that difference will be reflected in their rates. The rate in is 1/5. The rate out is 1/8. So that's 1/5 of a sink per minute, 1/8 of a sink per minute. Now, let's add those up and find the combined rate. So 1/5 minus 1/8. The common denominator is going to be 40, the product of those two, because they're relatively prime. And so we'll multiply this guy by 8 over 8, which is just another way to write 1. This guy by 5 over 5, another way to write 1. And there we have the 40, and 8 ones are 8. 5 times 1 is 5, and the difference is 3 over 40. So that is the rate when you have the faucet on and the drain open. So now, let's build our equation. So rate is 3 over 40 times the time, which, by the way, we're talking about this time right here, the time it takes to fill the sink when those conditions are going, and that equals 1 sink full of water. And now we have to isolate t, so we'll multiply both sides by the reciprocal, which is 40 over 3. 40 over 3. And so these divide out, and we get t equals 1 times 40 over 3 is 40 over 3, which in terms of a decimal equals approximately 13.3 minutes. And that is the time it takes to fill the sink when the faucet is open all the way and the drain is open, and we're done. For this next problem, it says translate into a mathematical equation, and we're talking about variations here. And by the way, when you talk variations, let me go over this. Direct, I'm just going to put a direct variation, dv, has the form y equals kx. Inverse, iv, variation, has the form y equals k over x. And joint variation, let's call it jv, has the form y equals k xw. Those are the three different forms, and you can square x or square w, and you can have the inverse of of x squared and so on. But let's do what they ask us to do here. The drag of an object traveling through a fluid d. So we've got d. They tell us exactly what we need to do. And by the way, there's always this k. That's called the constant of proportionality. So that will always be there. Traveling through a fluid varies jointly. So we're going to have a product, k and two other variables, jointly with the density of the fluid, rho, and the square of the velocity. Well, I'll square the velocity and we're done. We did just what they asked us to do.